As I said, I forgot my paper, so that's going to mean that your quiz from last week, which I think was quiz 4, I'll give that back to you. Most everybody, from my recollection, most everybody did reasonably well. The problem that I don't like about that quiz is that when you have 5 problems, how much does each problem cost? 20 points, because 5 times 20 is 100, right? And so each mistake is very costly, right? And then of course we have somebody to get back that. Let me turn this top thing off so we can see this again. Okay, one of the things that has been on the quizzes, and unfortunately it stopped as of this week, but it has to do with a classic area problem. Right? So I would like you to put this in your notes. Okay? Back in elementary school, if you were part of the new wave, you would use multiplication to solve this area problem. Right? And you would have 8 times 11, which is 88 square feet. Now, one of the things I want you to notice as an algebra student, how many feet? 88 what, though? Square feet. That makes this a quadratic equation. Right? It makes it a quadratic equation. And what nobody responded on this extra credit problem, nobody responded with a quadratic equation. And so very few points, but I think part of it is that you may not have been exposed in Algebra 1 to enough of these problems to understand what they're asking for. Okay? Does that make sense? All right, so I want to go over that because I think it's important. This kind of problem you're going to see several times. Okay? So, if the area of a rectangle, instead of being 8 by 11, which would be 88 square feet, if it was some value x that was extended both length and width, then the measurement would be 8 plus x, and the length would be 11 plus x. Okay? But because length and width are multiplied, what are you going to end up with when you multiply those two things together? You're going to end up with a quadratic equation. Because x times x is going to be x squared. Right? Now, what they have to give you is they have to give you the area of the new rectangle. Right? And what happens in a quadratic equation, the a in a quadratic equation is 0. So therefore, I'm going to have to take this value and subtract it, and where the 88 is, it could be positive, it could be negative, depending on how big the new rectangle's area is. Does that make sense? All right, so that's the equation that they're trying to get you to look at from a problem similar to this. Okay, so what happened is the 8 feet was extended by x feet this way and extended by x feet that way. So now this is 11 plus x and this is 8 plus x, and then that's going to give you your quadratic equation. Okay, now that's one. A similar problem, whoops, where am I at here? Okay. A similar problem would look like this. Down here, whoa, where'd it go? Hang on. There it is. Okay, suppose that this whole thing is 9 feet. The blue is 9 feet, and I have 2 parts here and here that are both x. Then what will be the red width? It'll be 9 minus what? 2x, one for the top, one for the bottom. 9 minus 2x. All right, this whole length was 12. Then what will be the length of the red? 12 minus 2x. All right, now there's your quadratic equation. You multiply 9 times 12, get 108. 2x times 2x is 4x squared, positive. And then I have negative 24 and negative 18 for negative 42. All right, now when you solve this using the quadratic equation, which we are going into chapter 5 to do, right? When you solve that, what in this particular thing, I put it out here for you, you end up with 1 and 9.5. Now, can x be 9.5? Why? Because this measurement is already 9. You can't have a negative measurement for a real figure, and so therefore this is an absurd answer. And so the only answer you can use is 1, an x of 1. So now watch this. 9 subtract 2. What's 9 subtract 2? 7. 12 subtract 2. That makes this 7 times 10, which is 70. Okay? So these are the problems that we've seen on the last 4 quizzes for extra credit. And I think I gave a total of 2 points extra credit on all 4 of those problems. All right? And so it's something that I probably should have addressed earlier, but does that help anybody? You begin to see. Now, you will see a problem like this on an Algebra II level testing problem for advancement, because it makes you have to use a quadratic equation to find the answer. Right? A lot of the other stuff is arithmetic answers, which if you're a decent enough math student, you can do the arithmetic if that's the level that it is. Right? But that's almost like a 7th or an 8th grade level. To be able to force you into quadratics, which will get you at a high school level, they have to do something like what one of those 2 problems are. Okay, does that make sense? Does that help? Okay, all right. All right, that's number 1. Now, if you will, make sure you get your Algebra 2 book out, because we are going to be working it today. All right. Now, second thing. All right, I'm going to kill that one.
Don't kill it.
Sorry. Sorry.
That's a pretty bad
All right. Let's see. All right, let's go here next so I can get rid of this one too. Ouch. Okay, this is the assignment for this week. All right, 411, which we're going to talk about briefly, and then chapter 12 is the review. We're going to do some of that today. We're going to talk about chapter 12, and then 5.1 and 5.2 are our basic quadratic equation problems. They're not very tricky, but we have one thing we have to cover today to get you ready for that part. You shouldn't find any problems here. Yes, ma'am? There's no test this week.
Okay, because it says graded assignments, not.
Right. There's no test this week. The self-graded, this is what I was supposed to give out that I already graded. Right. This one, don't worry about that, because we're out. Okay. Don't worry about that. Okay. Now, oh, the self-graded assignment, that's going to be the chapter test on 12. That's what that is. Because the chapter 12 is actually a test in the book, right? But you're going to self-grade that, and then we're going to do a chapter test out of Forrester later. Okay, so don't worry about that. Okay, but at any rate, so 11 is the part that we're going to have most difficulty with. So let me save that, and it's gone. Now, where'd it go? Here it is. Let's see. All right. Third thing. I was very frustrated with section 4.8. I don't have the videos. I probably could find them, but I don't have the videos. But the book itself was fairly straightforward on what you're supposed to do. The problem is when we were doing them last week, we made some arithmetic errors, and those arithmetic errors got us to where the answers didn't work out. All right, so that's the reason I said these. Okay, now what do you have to do for a matrixing? That's what this is called. What do you have to do for a matrixing? Number one, you have to know what the identity matrix is. Okay, now I'll throw that out as a question. What is the identity matrix? All right, what does identity mean? It's talking about how you identify something, right? Okay, we identify a matrix when we have a 1 here, a 0 here, and a 0 here. And then I know that 1x equals whatever that number is. Right? And so if I have a 1 here for the x, then these two things have to be zeros because I don't want, in the identity, I don't want to consider x in only just one equation. And so I'll have 0, 1, 0 in the number so that it says 1y equals whatever that number is. And then I'll have a 1 here with 2 zeros, and 1z equals that number. Okay, so this is an augmented regular matrix, and what we want to try to do is get an identity matrix. And when we have the identity matrix, this augmented number says that x equals 4, y equals -2, and z equals 1. Well, that's the solution to where those three equations cross. Okay? Now, what I did for you is, hello, you must be disturbing somebody because I shut the door. What I did for you was to be able to give you a demonstration on a number of those so that you could follow along. Okay, now, if you do not do a silly arithmetic mistake, matrices are easy. The problem is that a lot of times we make silly arithmetic mistakes, and so do I. Right? And so when we were doing this in the tutoring, we got about 50% of the answers right because we were taking turns, and I'm not sure who did the answer that was wrong, me or somebody else, but as soon as we got one number wrong, we never got the correct answer. Okay? So, what happens here? If you have an identity matrix goal, then you need a 1 up here. Well, this problem is going to be nice, isn't it? Because I already got the 1. Now, how do I make a 3 turn into a 0?
You can multiply the top row by 3.
Multiply the top, not by 3. Multiply the top row by -3 and add it to the second row. Okay, now, why multiply by -3? Because if you're doing a negative number in here, you make less mistakes when you add than you do when you subtract. Because subtracting a negative is a difficult thing to do mentally. Remember, subtracting a negative is the same as adding a positive, right? So if you stick with just adding and get the opposite number here, so if I have a 3, I need a -3, right? And so what do I multiply this last row by to get to 0? What am I going to multiply the first row by so that I get a 0 here? -5. So that will be 1 times -5 plus 5, which is 0. And then it'll be 3 times -5, -15 plus 7, -8. And then -5 times -5. How much is that? -5 times -5, 25, 25 plus -3 is 22, and then -5 times -7 is 35, 35 plus 3 is 38. So that's the manipulation of those rows. Now once you get this down, then you've got to start looking for either a 1 here or or 1 here, someplace to find the 1. And this one was pretty easy, wasn't it? 5 minus 4 is 1. So, right, so I'll end up putting these two together, combining these two, and putting them in the second row because I want the y to equal 1. Now, eventually, I got to get a 0 up there. All right, but that's how the following through the pattern. That's how you create the identity matrix from the matrix that you begin with. Okay. Now, the arithmetic is critical, and it takes a lot of paper. Right? So people that don't like to write a whole lot, they end up having a real difficult time busting through this because, in my experience, one decent problem will take almost 1 page for one problem. And if you'll notice, even when I wrote it out, it almost was the same thing. Okay. So, any questions on 4.8 as far as you're concerned? That was the assignment that you were supposed to have finished this past week. Okay. Any questions on that? All right. Good. Okay. Now what we're going to do is look at a preview of what's coming up in 4.11.
Yay!
All right. So. Well, okay, let's see, how do I do this? All right, now, let's see, I'm trying to figure out how to present this. All right, what I did is I took the answer key and made a picture of it. All right, and you're supposed to graph several equations, right? Now, if you'll notice, they actually give you the equation. One of the equations says that G was greater than or equal to 2 times B. Okay? Now, if the B is down here and the G is down here, based on the numbers, they use 10 for each point instead of 1.
Right.
All right, now, that's one difficulty in itself. But, let me ask you a question. G is equal to 2B is the line. Right? Okay. How do you graph that? Y equals mx plus, what's the B of the general equation? The B is 0, 0. Okay? Now, what's the slope?
2.
2. So I'm going to go over 1 up 2. Over 2 up 4. And then draw a line. Now, this is where it equals. Right? Everything, if it says greater, you have to be above that line. Alright, now, it also said that B has to be greater than or equal to 5. Well, that's a vertical line. Because B happens to be the x-axis. Right? Now, where is everything that's greater than 5? It'll be to the right side of that line. Again, so that's saying that this part is not. Now, technically, the way that I've learned and the way that I taught this type of problem was that when you get the area that meets the criteria for all the information, you have 1, 2, 3, 4 points. Right? And then you have a base problem, which we'll see in a second. Right? And you check all 4 of those points. One of them will be a maximum, one of them will be a minimum. And how do you know which one? Test them. The biggest number is the maximum, smallest number is the minimum. Right? That's the way we used to do that. Now, here's my question. This point right here has the B of 5. Look at the line. It says G plus B is equal to 50. Well, if B is 5, what's the G? If G plus 5 is 50. 45. So that makes that point 545. Okay? Now, how would you find this point? You would have to do the same thing, and you would have to compare compare this equation with this equation, right? And then there's another, the book had another form for that one, right? So, and to find this point, you have this equation and this equation. Well, this says G is equal to 2B. What's 2B plus 1B? 3B, right? If 3B is equal to 50, if 3B is equal to 50, then B is equal to 50 over 3, 16 and 2/3, or 16 and 2/3, 33 and 1/3. That's that point there. Okay, now, in the problem, you had to have whole numbers. So that means you have to choose either 16 or 17. Okay? All right, now, let me show you what happens with this problem. Okay, now, in the linear programming, which is the name of that skill, you are given an additional equation. That equation is right here. And the X and Y points, or the G and B points, are put into this. Now, if you solve this problem, it says guitars cost $750, electric bass costs $900. You have to spend how much money? Okay? Now, the point that we talked about was 16 and 34, because what is 16 plus 34? It's 50. Okay? So if I put the 16 here and I put the 34 in there, I'm gonna have a value. If I took the other points and replaced the G and the B, I would have a value. And then the question says, what is the value that will create, I can't do it that way. There. Come on, you can do it. What's the value of that point right there when you use 16 and 34? Right? And that's the question. This ends up being the optimum or the maximum value. So if he's planning, he needs to know one of two things. He needs to know what's the minimum amount that I need, and what's the maximum amount that I'm going to spend. Right? So this is actually a business model. And these equations are assumptions that the businessman uses, and then he analyzes his financial needs based on mathematics. Okay? And this is used quite often in the economics and business field. Right? But for our purposes, we're trying to find where these points are, and we're graphing the equations and then determining based on greater than and less than which section is the section that will be true for all equations. Does that make sense? A little bit? Okay. All right. So let's see if we can get to the next one. If I can see that, it would be wonderful. Okay. All right, now this is problem 2. All right, now, problem 2 says, and I can't remember T and C, and I can't remember what they are right now. But the amount, oh, I know, it was 2. This was Texas and this was California. So if you get oil from Texas, it costs you $30 a barrel. If you got oil from California, it costs you $15 a barrel. And according to this, you had to have a total of 40,000 barrels. So if you had a total of 40,000, then T plus C is equal to 40,000, and then the cost would be 30 times the barrels from Texas plus 15 times the barrels from California. All right, that's just basic algebra, right? Does it make sense so far?
Yeah, I just don't understand. Texas
Well,
costing more than California. California jacks up the price of everything.
I think because I agree with you in that part, but it has to be transportation costs. That Texas was farther away, and so therefore the cost was higher. Now they gave a whole bunch of different things. Okay? And so what you had was, here's 2t plus 6c is greater than 120,000. This had to do with impurities. That every barrel had 2 kilograms or whatever it was of impurities, and everyone from California had 6, and the most that your refinery could handle was 120,000 a month. Right? So therefore you have to get an equation, and it has to be less than that. Right? Because of the limit that was on the refinery. All right? And all of these were just equations that you were given, and I'm not going to go into the details, but I wanted to show you this, is that you had to be greater than this line, which puts you up in this way. You had to be greater than this line, which puts you over here. You had to be less than this, which puts you down, and less than this. And so that became the area of truth for all the equations. That's a simultaneous solution. Now, what you do is you look at the 4 points. Okay? Now, this says Texas, the T is cut off, Texas plus California is equal to 4,000. Right? Well, right here, the Texas is 0, and so that's 40,000, and on the scale, they used a 4. This is supposed to be 10,000s, not 1,000. All right, that was the first thing I saw. All right, but right here, I have 4 10,000s and no 10,000s. That will be on this line, won't it? Right? 40,000 plus 0 is 40,000. So that's an optimal point. This one right here is on this line. Right? And so when the California, see, is this California? Yeah, this is C, right? So when the California is at 0, I have 30t is equal to 6, and that's going to give me 2.2, because 2.2 times 30 is going to be 66. Right, so that's another point. How do I find this point? It is the solution of this equation and that equation together. Now that's what we were doing in the previous chapter, right? We were doing 2 equations and 2 variables and finding the solution. Well, the solution is this point if you take 30t plus 15t equals 660 and 2t plus 6t equals 120,000, right? Those 2 things right there will be that point, and it ends up being 1.4 and 1.5. Right? Now, when you take those numbers and you put them into the formula for value, right? You try to find out which one is which. Well, I did that here, right? 30 times 40,000, which is this one, is 1,200,000. If I take this point, which is 3 and 1, is 30 times 30,000 plus 15 times 1,000, right? That's 1,050,000. That's cheaper, right? So right now, this is the most expensive. And when you do the other 2, you end up with 660 each, and there's a reason for that, is because you're on this line, and this line equals 660. Right? And so the question is, what's the most money that they're going to have to plan for? And so this is what they're going to plan for. The optimum comes from this point right here. And we used to just check these 4. Okay? Now, usually one problem is a project. Right? And when you work on that this week, look at it that way. Try to understand how to, first of all, can you plot the equations? That's the first thing. And then the second thing is to figure out where the points are. Right? And there'll be one equation that deals with monetary value. That's what you're looking for. This is the one where the T and the C are placed in to be able to get the values. Right, does that make sense? I know that I don't particularly care for this chapter, right? Because number one, it's really hard to test unless it's given as a project, right? And so, but I'm trying to show you what you're going to have to do. I will show you this just for your looking information. I don't know if you can see that, but I worked the problem out. That's what you're going to be asked to do, right? The graphing of the equation is the hardest part. Okay, all right. So, all right, questions on that as an introduction. Okay, good luck with this. Don't worry about this too much. All right, it's something that you should understand conceptually. All right, but if you had a test on it, they would give you the equation and they would have to give you these points to make it fair. Or the equations would have to be simple enough that you could find the point. Does that make sense? Either by looking at where it intersects the line, or by taking this equation and this equation and solving it. Now, is this a simple one to solve? No. No. I was really disappointed with the scale, and I think I found the mistake, because that was supposed to have been a 10,000, 1 every 10,000 instead of 1 every 1,000. Okay? All right, so far it's been pretty boring. Okay? Now, okay, this is problem 4, and the value at the top says the cost is 6 cents times X and 5 cents times Y. Okay? But you have to find these optimum points. All right? And so I found the values, and that's what's in the parentheses, the values for these points. And when you put them in the equation, you have this amount. So the question asks for what is the least amount of money that you're going to look for as far as cost is concerned. Of these 4 numbers, what's the smallest number? 0.21, 21 cents. Right? What's the largest number? 51 cents, right? And so if the question had said, what is the least and greatest amount that you could expect giving these limitations, you would say somewhere between 51 cents and 21 cents a unit. Right? If they asked for the average, what would you do? How do you find the average? Add them all up. In this case, and divide by 4, and that would give you the average, right? And so a lot of times the problems were relatively straightforward after you found out what these points were. Okay. All right. Now, all right, I did that was enough for examples. I ran out of time because I actually watched some television last night. So, okay. All right. Questions on that? I know I've gone over that relatively fast. Don't want that. All right. Uh-oh. All right, now, textbook. If you will, turn to page 169. Let me see how I can do this here. All right, I can't do that. Okay. All right, 169. The problem R1 says linear combination. Linear combinations. What's that mean? All right, linear talks about lines that have AX plus by equals c, or y equals mx plus b, right, has that type of format. But a linear equation has x and y with power of 1, an exponent of 1. Right? And so when you have this, what all the linear combinations is talking about is eliminating one of the variables to solve for the other. Okay? Now, so the problem says 5, negative 8, 47. And 2, 7, negative 22. Okay, now, what did I just write? Matrix, right? I just wrote matrix. It doesn't ask for matrix, so that means I have to put the x and the y and the equal sign in there. Okay? Now, I have the same problem that I would have had it been a matrix, and that is I need to find 1x. How do I find 1x? Alright, do you see the 5 and the 2? What do you want to get 1? You want 5 subtract 4, right? How can I make this into a negative 4? Multiply it by negative 2. That's exactly what we do if we were doing the matrix, right? So now 5 plus negative 4 is 1x. Right? Now, this is negative 8 plus negative 14, which is negative 22y. Right? And then this is, I don't even want to do that here. This is 44, oh that works. 44 plus 47, which is 91. All right, now that's what I would get if I was doing the matrix. Okay? However, if I'm doing a linear combination, I need to eliminate one of the variables. And so there's two things I can do. I can eliminate the x and eliminate the y. If I have a negative and a positive, if I multiply the top row by 7 and the bottom row by 8, I'll have 56 and negative 56 for y. Okay. So if you're asked to do a linear combination, you're trying to find a 0 for one of the variables. If you're doing a matrix, you're finding a 1. See the difference? Yes, no? Make sense? Okay. Now, which is easier?
Combinations.
Huh? Sometimes combination is easier, right? On a 3 by 3, it's pretty difficult. A 3 by 3, the matrix is certainly much easier. All right, what's another way that we can find the x and the y here? Something that we used last week. Kramer's rule. All right, what do you do for Kramer's rule? Right? You don't have to worry about changing the numbers, you just have to use them correctly. All right, Ruben, what's the denominator if we were doing Kramer's rule? What's the denominator for these two equations?
5 to 8, 7.
No, 5 times...
Yeah, 5 times 7. 8.
Which is 35, minus... 2 times 8. Which is negative 16, which would be plus 16. Right? And then the top part, usually on the top part, we make another matrix. We take the two answers and then use the y values. And then over here, I'm going to put the two answers on the y and use the x values. So the numerator is going to be 47 times 7, subtract negative 22 times negative 8. All right, that will be the numerator over 51. And then this one will be 5 times negative 22 minus 2 times 47 over 51 again. And if those are whole numbers, then this will turn out very nice. If those are not whole numbers, they're ugly and leave them as fractions. Okay? Make sense? All right, now, on page 169, problem R1b. It says, solve it by determinants. That is Kramer's rule. Determinants is Kramer's rule. All right, you may want to put that in your notes. Determinants is Kramer's rule. When it's a 2 by 2. Now, there's actually a way, and there's a formula for doing determinants on a 3 by 3, but it's a little bit more involved. Right? But determinants is Kramer's rule. So, if you're going to prove that you know how to do linear combinations, right? You're going to have to show that you can get 0 and work with the other value. Right? If you're going to use a matrix, you're going to develop the identity matrix in an augmented form. Right? And if you're going to do a determinant or Kramer's rule, you're going to do a third thing. So there's 3 different methods that you have to show that you can do. Right? And one of the things that I've said for a long time about Algebra II, Algebra II is probably, in my opinion, for sure, in my opinion, Algebra II is the hardest high school math class to take because there are so many different skills that you have to master. It is not a simple class. Trigonometry is easier than Algebra 1 because you're working with just one basic skill. Right? Now, trig is fun. It's actually fun. But it isn't so broad that you can't figure out how it's working. And once you see how trig works, it's just a puzzle. Right? And it really is a lot of fun. But Algebra 2 in general has so many skills, and we're talking about how many skills just on this one problem. We're talking about 3 different skills. And they're almost completely different, aren't they? Right? And that's what makes the algebra so challenging, is that the skills are specific skills. They have vocabulary words attached to them. And 6 months from now, when you take the final test, you've got to remember what a linear combination is. You have to remember what a matrix is, and you have to remember what a determinant is talking about. Okay, so that's the reason that we're going over that. Okay, let's turn the page. Okay, now, all right, I'm going to skip R2 for the second and go to R3. All right, what do you see in R3?
It's a 3 by 3.
A 3 by 3. How do we solve a 3 by 3 matrix? That's 4-8. You're going to use a matrix, and you're going to have a 1. Okay, now, there's 2 ways to get a 1 on that problem, on R3. Name one way we could get a 1 in the x position.
Is it just divide it by 3?
If you do divide it by 3, you're going to end up with fractions. Right, so what you want to try to do instead of that is that you want to combine 2 equations to form a new equation that has 1 for the x.
Oh, combine the 2.
All right, so you could combine you could take 4, equation 2, subtract 3, equation 1, or you could take equation 1 and subtract equation 3. Either way. Right? And that's the hard part about even showing a solution, is because there's more than one way to attack it. Right? The way, if they only show you one way in the book or one solution, then you might see a different way to start, and none of it makes sense based on what I would write down. Now, what would you take 4 minus 3 or 3 minus 2? Let me ask you that. You would? Okay. I think I might do 3 minus 2. All right, just because it's a smaller number. All right? So the first thing is going to be 3 minus 2, and then I've got negative 3 minus 5. How much is that? Negative 3 minus 5. It better be negative 8 if it's something else you've already messed up. All right, and that's the hard part about it. If you are not good at integer arithmetic, put it in the calculator every time and verify that the answer you're trying to get is agreed by the calculator. Okay? And if not, the second thing you should do is make sure you put it in the calculator correctly. All right? Because if you're supposed to be subtracting, what happens if you add in the calculator? All right? You could have had the right answer in your head. If you punch it in the calculator wrong and the answer doesn't agree with you, make sure that you put it in the calculator correctly before you decide that the calculator is smarter than you. Because the calculator is not smarter than you. The calculator only gives you the answer of what you give it. It doesn't know what the right answer is. Right? And so if you put in 5 minus 8 instead of 5 minus negative 8, you're going to get a different answer. So be careful with that. All right? Okay, so problem R3 should be relatively simple. All right, and you should right now, I hope that right now, you could say, given time, I can handle R3. All right, I know what to do. All right, would you agree?
Yes.
Right? All right, and that's the thing, is that learning the algebra is one thing. Performing the arithmetic that goes with the algebra is the second thing. All right? And what I'm looking for is whether or not you've learned the algebra. All right? The arithmetic part of it, you know, I made mistakes on Friday during tutoring on the arithmetic part. And it was really frustrating for me. It was really embarrassing, but I didn't let on like I made the mistake. But I did make the mistake, and so the answer didn't work out. Now, we learned the process, but we couldn't verify that the answer was right because we made an arithmetic mistake. Okay, now, R4, what does it say? See that G word? All right, G word is really tough. Graph. Okay? All right, hate graphing. But we need to look at it. Okay, now, first of all, whoa. I got stuff all over my board. Alright. Okay. Alright, the first equation says y is greater than or equal to 3x plus 2. Okay. Now, Algebra 1 student, how do you graph that? Where do you start graphing this thing?
2.
You better start at 2, right? At 0, comma 2, right? And so the first thing I do is I have a point right here. Now, what's the slope of that line?
3.
3. That's up 1, 2, 3 over 1,
Yep.
up 1, 2, 3 over 1, and down 1, 2, 3, back 1. So I have a line like this.
Yes.
All right, now, that's the first thing. That's the equal part. Now, what does this say?
Y is greater than.
Greater than. That means I'm going to be above. So this is y equals 3x plus 2, and I need to be above it. All right, so I'm going to do that. Okay, what's the next line say?
2x minus 3y is greater than negative 15.
2x minus 3y is greater than
Negative 15.
negative 15, okay? Now, that's not in the form I want. So, I'm going to subtract 2 and divide by negative 3. That's going to be positive 2 over 3x. If I subtract the negative 2 and divide by negative 3, it'll be positive 2 over 3x. When I take the negative 15 and divide it by negative 3, I'm going to have plus 5.
And don't you have to change
So
the
now
sign?
I have this. All right, question?
Wouldn't you have to change the sign since you moved negative?
Thank you. That was where I was going next. Thank you. Okay, now, because you divide by a negative, is this sign correct?
No.
No, you have to reverse the sign. Okay, so now how do I graph that? You graph it where it's equal. So where do I start?
0, 5.
I'm going to change colors just because I can. All right, so I start here at 5. Now what's the slope?
2 over 3.
All right, up 2 over 1, 2, 3. Up 2 over 1, 2, 3. And down 2, back 1, 2, 3. And now I have this. Now, it says less than, so this is y is less than 2/3 x plus 5, and I need to be below that. Actually, what I should have is this. That's y equals, and I want to be below it. All right, now, third line says,
Too much for me.
all right, now, this is a point slope. If you look at the third one, this is a point. In this case, notice that it's 2 pluses. They're supposed to be negative, so my x value is -3, and my y value is -2. So I start here. Now, what's the slope? -2 over 5. See it? So therefore, I go down 2 and over 1, 2, 3, 4, 5. Down 2 and over 1, 2, 3, 4, 5. Up 2 and back 1, 2, 5. All right. So now I have a line that goes like this. Now what does it say about that? It says y is greater than. So I need to be above this line. All right, so it looks like this is going to be this area right here, doesn't it? Huh?
It's going to be right there.
It looks like that's where it's going to be. All right, now the last one says y is greater than -1.
So it's just the...
All right, and I got what color I need? Blue? All right, y is greater than -1 is like this. Right? And I need to be above that line. So I'm going to have to extend my red line down a little bit. All right, now, so now I have a quadrilateral. I have a quadrilateral that has a point here, a point here, a point here, and a point up here. And so that's the region where, so any point that's inside here, let's take, just for instance, let's take the point -2, 2. -2, 2 will make every equation true. All right? When x is, now this was greater than, right? When x is -2, this is -6 plus 2. -4, this is 2. 2 is greater than -4. Is that true? Yes. Right, the same thing would be true here. All right, that is that one. All right, here. What happens when x is -2? This becomes a negative number, right? Negative number less than 1, so that'll make this 4, but this is 2. 4 is bigger than 2, and so it'll also be true. All of them will end up being true in this area. Now, what happens to this point? 0, 0.
It's left out.
Okay, now, we're supposed to be above this line. It will make the blue equation true. We're supposed to be above the green line. It'll make the green equation true, but these two equations will be false.
Well, the red is true. It's below. It's below.
Oh, I'm sorry. Okay, the red one is true, but the last one, this one right here, it will be false.
Right.
Okay, and so when you begin to analyze them, that's one of the ways that you analyze. Okay, so that's the area. Now, first of all, question: how hard was this to graph?
So easy though.
No, it wasn't simple. It wasn't simple.
It's the only thing I understand is the
All right, the graphing part of it, they gave you 3 or 4. I think they gave you 4 different styles of equations, right? And so you had to graph them correctly. Once we changed them all to slope-intercept, they were pretty simple,
Yeah.
right? But each one of them had another skill from Algebra 1 that you were supposed to bring with you, right? You see how I'm saying?
Yeah.
So this was not a simple problem. This was a very complex problem as far as algebra was concerned. Right now, is this doable? If this was your only test,
I would pass.
you pass. Okay, what about you guys? Would you, if this was the only problem you had on the test, would you pass it?
I think so.
I think so too.
Can this
Right.
just be my final? Can this just be the
That's your that's one of your finals.
Okay, I can do that.
Yeah.
That's the final. I can get that over. That's
Right. So again, so as far as Algebra 2 is concerned, why is this an appropriate Algebra 2 problem? Because it presented the linear equation in 4 different ways. The only thing they didn't do was give you one of these.
Ah, that was vertical one.
X equals, what is that, -5? The only thing they didn't give you was a horizontal one, right? Which would have done what? Which would have made this not part of the solution. So then I would have 1, 2, 3, 4. Now, what does that look like? Doesn't that look like a linear programming problem, which is the section you're about to go to?
Yeah.
Right, it is. Right, but the graphing of it is an appropriate skill for Algebra 2 and one that you should be able to do. Okay, don't make silly mistakes. All right, remember that in this this one here, where was it? This one where we had the point slope. Right, instead of starting at 0, 0, right, when x is 0 and y is 0, this is 2. Right, that's why we started at 2. Right, if you have y plus 3 is greater than or equal to 2/3 x minus 1, instead of starting at 0, 0, because if you put a 0 here and a 0 here, the numbers don't help you as much. So we know from this that I have an x of 1 and a y of -3, so I'm going to start at that point and use the slope of 2/3. Right? And this used to be stressed in Algebra 1, but a lot of people now sort of skip over it. And so when it's given, you don't understand. This is just simply a third way of representing a linear equation.
Right.
Okay? All right, now, the next thing I want to do is over on the test T2. How am I doing for time? 15 minutes. Thank you, Lord. Where's my red? There it is. Okay. All right, now, next part is another notes thing.
Lucky I got my notes open.
Okay. And I need new paper, so I think I'll kill that. Yes. Okay, now, I'm going to try to relate something that we've been doing with something that you're going to have to learn to do.
Okay.
Okay? Now, we have had y equals mx plus b. What does that represent? A linear equation, right? And the x and the y are your variables.
Right.
Okay? Now, if I asked you for a quadratic equation, you would have this. Write that down in your notes. Okay? Now, this is a quadratic. See the x squared, right? This is linear. Now, if I told you that the point 1, 5 was was on that linear graph, what do you know for sure? I know that y is 5. I know that for sure. Agree? If I gave you the slope, you could find b. If I gave you the b, you could find the slope with simple algebra. Okay? But what did I do with the x and the y? I plugged them in. I replaced the x and the y of the general equation with the values of x and y from this point. Okay? Now let's do the same thing over here. Let's say the point is 2, 3. All right? Now, what do you know for sure? I know that the x is 2. Well, what does this say?
X squared.
X squared. Well, what's 2 times 2?
4.
So that means this is 4a. All right? What is this? 2b plus c equals 3.
Okay, so wait.
Okay? That's all it is. That's because I know x, and this is f of x, right? Which we usually set up to 0, but this is where the y is. Right? So I have that equation.
I thought the y was over there. It was a y.
It is, because this is f of x. And f of x is the same as y. We set it, why do we set it equal to 0? Is because we want the values on the x-axis, because that's the solution. That's why we set it equal to 0.
I get it now.
Okay? Alright? Now, so let's say that I have another, let's say I have another one. Let's say that I have 3, 4. What would that do here?
It'd be
The 3, what's 3 squared?
9
So this is 9a plus 3b. This is just use the 3b plus c equals 4. Alright? Anybody see what I'm doing?
Yes, I get it now.
What am I doing? I'm just replacing, but what am I beginning to make?
You're making
The
the
matrix.
Huh? Say it, Ruben?
I know what you're doing. Just put up a name.
It's a matrix. I'm beginning, but I need what? In order to have, if I have 3 variables, I need 3 equations. So that means I got to give you another point.
Yay.
Let's see. 5, 7. 5, 7. Okay? That'll be 25a plus 5b plus c equals 7. Okay? Now, if we were doing a matrix, all right, we have tried to make a 1 over here, right? Does anybody see anything? If you had to make a 1 someplace else, what would you rather do? What about 1 minus 1? Alright? I got a 1 right there, don't I? And 1 minus 1 will be 0, and 1 minus this 1 will be 0. So instead of working with the x's, I could work with this column and come down to a 2 by 2 really fast. Okay? Now, after you got done, you would then go back to here. Right? And let's say that you found that C, let's do it this way. But we ended up with this when we got done. What does this say? A, it's A equals 1. If A is 1, that's x squared. Right? What does B equal?
4.
That means plus 4x. And what does C equal?
15.
Plus 15 equals 0. And so given 3 points, now that we have worked on matrices, and now that we know how to solve matrices, right now we can jump from linear equations to quadratic equations. Now, I'd have to give you 2 points here to be able to find the slope, right? Right? Because if I gave you this one, and let's take 2, 3. What's the slope? 5 subtract 3 is 2 over 1. The slope is 2. Right? And so I have a 2 here. Right? 5 equals 2 plus how much? 5 equals 2 plus 5 equals 2 plus 1? Come on. 5 equals 2 plus
B.
3.
What?
5 equals 2 plus 3, doesn't it?
Where'd you get
Yes.
the 3 from?
Because 2 plus 3 is
Because this is the 5.
Oh.
The y is 5, the x is 1, my slope was 2. So that makes y equals 2x plus 3 the equation of the linear given those points. If I gave you 3 points, now these two, I made these up so that they may not go together, right? But given these points, you can now solve this matrix for A, B, and C, and now you can create the equation for the quadratic, just like we had for the linear. Now, that introduction is that problem in the test. It's not anywhere in the chapter. That's the reason I wanted to get to that.
That's nice.
Okay.
Nice like that.
All right. Now it's important that you can do this. This problem is on your midterm that you're going to have just before Christmas.
It's a big section. Oh, lovely.
Right? Okay. But again, we're just learning how to do it. Right? As we get into chapter 5, you'll have more practice with this.
I have a question.
Yes.
Will there be a study guide for midterm?
I don't know.
Is that I would just study the quizzes.
Yeah, why he's the...
You know, part of, see, there's 2 things. You can review the types of skills you're supposed to know.
Yeah.
I will do my best to tell you that. Is that, like, for instance, I've already told you that Kramer's rule will be on the test, determinants will be on the test, right? That the linear combinations will be on the test.
Yeah.
This skill for given points finding the quadratic equation will be on the test, right? Because those are major skills. Okay. All right. Well, good. Good day today.
Thank you.
God bless.